So here we go with solving modulus problems. Now this we should be fairly good at with the prep work we've done on starters. So given the function t of x is equal to 3, the modulus of x minus 1 minus 2, x is a member set of the reals, sketch the graph of the function, state the range of the function, and solve the equation. So let's begin by sketching the graph. And I like to do this by building it up. So let's start with y equal x minus 1. We know what that's looked like. It's gradient 1. It would be going through minus 1. So that would be negative 1. If we now put the modulus signs out, we know that that reflects it in the x-axis. So we've got y equals x minus 1. And the reflection of that, which is y equals the negative of it, so we get negative x plus 1. Okay, now we've got to multiply that by 3. So we've got y is equal to, or we could have, y is equal to 3 lots of the modulus of x minus 1. And hopefully we know that that is a stretch scale factor 3, f of x maps onto 3 f of x with a stretch scale factor 3, and it's outside, this is outside the function. So the change is going to be in the y direction. So the x-axis is invariant. So our sketch is now basically the same as we had before, but it's going to be steeper and steeper. And instead of going through 1 here, it's going to go 3. This point would still be out 1. So this line is now 3 times what it was before. So it's 3 lots of y equals 3 lots of x minus 1. So it's 3x minus 3. This line is y equals 3 lots of minus x plus 1. So we get minus 3x plus 3. Okay, so we've got that. We've now got to subtract the 2. So we've got minus 2 here. So again, our knowledge of transforming graphs is important here. So f of x mapped onto f of x plus a outside the function. Yeah, plus a is outside the function. So it's going to be a translation because we're adding stroke subtracting something. And it's outside the function, so the change must take place in the y direction. So it's a and 0 across. So here we're going to translate the graph down 2. So our answer is going to be here, down 2. I'm just going to move that slightly. So it's fairly steep. It's going down 2. Its gradient is 3. So that's going to come out. So it goes just positive, I think. Whoops, that wasn't really very good. Let's just try that and draw that again. So we're going to come down and then it's going to be down here, except I need that to be positive. Yeah, if I need to, I can move it around afterwards. So if that point was 1, 0, yeah, 1.0, it's been moved down 2. So that's going to be out 1, 1, negative 2. Okay, the line was at 3x minus 3, that's this line here, was 3x minus 3, and we've subtracted 2 from it. So we're going to have y equals 3x minus 3, take away 2. So this is y equals 3x minus 5. This line was y equals minus 3x plus 3, but we've got to take 2 away from it. So we get minus 3x plus 1. So we've got our two lines, or we've got our graph of t of x. State the range. So the range is the output values. So that's part A. B, output values. Yeah, range is the output values. Outputs as its range. And if it's range, so it's got to be described in terms of not, I don't know, write f of x, but actually this time it's t of x, isn't it? Because our function is t. So range t of x is a member of the set of reals, but it's not all the reals because we're looking at the outputs which are up here. This is our output value, and our lowest one is -2. So t of x is greater than or equal to -2 for our range. Part C. Solve the equation half x plus 3 is equal to t of x. So if we add that line onto the diagram, x plus 3, it's shallower. So this is the line y equals a half x plus 3. We're looking for the 2 points of intersection. Well, the x values at those points because we're solving a function in x. So if we look at this left-hand one, that's the intersection of the line half x plus 3 and minus y equals minus 3x plus 1. At the point of intersection, the y values are the same. So we can write minus 3x plus 1 is going to be equal to a half x plus 3 at that point. So minus 3x plus 1 is equal to a half of x plus 3. And now it's a Year 7-8 linear equation. Multiply by the denominator, so we get minus 6x plus 2 equals x plus 6. Move the lowest number of x's, so we get 7x plus 6. Subtract the 6, minus 4 equals 7x. So x equals -4/7. If we take the right-hand one, again we've got the line y equals a half x plus 3. But this time it's intersecting with the line 3x minus 5. So we've got a half of x plus 3 is equal to 3x minus 5. Multiply by the denominator to get it on one line. Give 6x minus 10. Add the 10. Is 16 equals 5x, so x equals 16/5 as our answer. Hope that's clear.